This week's episodes were brought to you by the generous support of Andrew Henninger. So, welcome to this Unity program tutorial where we are going to talk about sharing data between scenes, because you can change scenes in Unity, right? So let's say we go ahead and we make a couple of scenes. So we're gonna save this scene as I don't know. Let's imagine we're making a game like Super Mario World, right? Or Super Mario Brothers 3 or whatever. We have sort of an overworld, and then you have individual levels. So we'll have one scene. This is like, I don't know. This is our main menu, right? And then we have another scene called Overworld. And then we have another scene, save scene as, which is like level 1-1. Okay, something like that. And then so on and so forth. It's very easy to imagine that sort of situation. Squill and IRC is open to other people. The Twitch chat is always been an IRC-based chat. And some people collect directly to it with an IRC client as opposed to the web. That's all people are talking about over dares. Okay. So imagine we've got this sort of scenario, right? And it's easy to imagine, like, okay, in a game like Super Mario, or something like that, we have lives, we have score, we have perhaps like a progression that we're trying to keep track of, you know, like what levels have you defeated, what have you unlocked, that sort of thing, which bosses have you killed, so on and so forth. There's a lot of different things that you might want to track. And normally when you switch from one scene to another, all objects get destroyed, right? So let's say, over here in the overworld, I have some sort of object. I'm going to create an empty on it, and hey, we got a tip from Garden of Sinners. Where can I pull that up? Hey, Garden of Sinners, yay to booze-inspired programming. Okay, no booze yet, not for me. You guys have fun, do what you want. But I will be focusing. Once we get to the multiplayer TF2, then often there's a little bit of something to make that a little bit more silly. Yes. Okay, so we're going to create an object in here. We're going to call it something like game manager, game status. Let's call it a game status object. Okay, and we're going to add a component to it. And I'm going to create a new script called game status. Obviously, I could have created the script I'm pointing at the screen because that helps so much, right? We could have added the script here in the project by going create C# script, or you can, as a shortcut, just sort of fill it in there. But in any case, we end up with a script called game status, and it's attached to our object called game status over there. Robojeb with the Ray sub. Of course, Robojeb also really helpful at steering ships in Kerbal Space Program. Okay, so we've got our script open. Let me embiggen this for the stream. That looks pretty big. Right, so standard sort of mono behavior thing. And let's imagine that we've got something like, we'll make it public for the sake of argument so that we can see it easier in the inspector. I mean, we could also use a serializable field, but let's forget it. Let's say we've got something like num lives, which starts at, 3, and public int score, which starts at 0. Right, we have some values on this. This is how we keep track of the status of our game overall. Stuff like that, and we have extra data structures. So we have this, and it's great. So right now, we are in what scene? We are in our overworld scene. So let's actually, to make it a little easier to remember, let's just add a UI element here for text. And I am going to, just center the text and say, right, overworld, just so that we remember where we are. We're going to center it. I'm going to make the font nice and big. Maybe that's too big. There we go, like that. Oh, there we go. Got to stretch the thing. I'm just filling the screen with this so that we can see what's going on. And let's make that bright white. And actually, let's change our camera background to be black. Okay, so we're on the overworld scene right now. Very clear. So now, and we've got this game status, and we're keeping track of the stats. But now we load level 1. And to load level 1 in the game, I guess we could actually go and implement this. That's probably good for our example. So let's add a button. Now, normally, how do you load level 1? Well, in something like Super Mario, you make sure your character's walked over to the level 1, and then you click, whatever button it is on this particular game. So you hit X or A or whatever it is, and it loads level 1-1. For us, for simplicity, we're just going to create a button. So in our canvas here, I'm going to create another UI element here. It's going to be a bouton, and I'm just going to label this to say load level 1-1. Okay, and I'm going to grab this button and just, I don't know, put it down in the bottom left corner. Doesn't matter where it is, but we gotta have a button on screen, and when we click this button, it's gonna load level 1-1 is the idea. So to do that, what are we gonna do? Well, let's go back to game status. May as well add it there. We could add this sort of function anywhere. There we are. And let's make a function. Who's that? Roller Rocker with the resub. Half year. Thank you so very much. Void load. Let's make a function called load scene that takes a string with a scene name like that. And to load a scene, it used to be you would go application.load level, but now you have to using Unity engine.scene management, which lets us do a scene manager.load scene, which takes either an index or a string, and we'll just pass it the scene name. Like that. So now that we have this public function here, to make our button work, and we're not going to go into the details of how, you know, the UI canvasy stuff, but basically, your button has a little field here. When the button gets clicked, it can let something know that the button has been clicked, so we're going to add an entry to that. It needs an object, so we're going to point game status to it, and then from the game status object, we're going to choose the game status script, find the load scene script there, the load scene function, which takes one parameter over here, and so we can tell it that the string it's going to load is level 1-1. So, if we hit play now, and if we hit the button, I was going to say we're going to get an error. The reason we're going to get an error is because you have to tell Unity all the scenes that are loadable. And we do that from going to File, Build Settings. I mean, it tells us right there in the error. And we're going to make sure that all of our scenes are in there. So Main Menu, Overworld, and Level 1. And the very first thing in this list is the thing that gets loaded automatically when the program starts. So that's the sort of order we can do things in. So now if we hit play, and we push the button, there we go. A new scene has been loaded. We can see at the top of the window here that we are in scene 1-1. We can make it a little bit more clear. If we go and manually load level 1-1 here, and again, we'll create a piece of text. We're going to make it fill the screen, and be centered, and be larger font, and be... Tell you what, for this one, we're going to make it white text. No, that's what we did last time. Let's make this text black, and we'll make the camera background white. Make it really, really obvious. And we're going to change the text to say scene, oops, it's not here that we change it, it's in here. Scene 1-1-1. Okay, so now again, if I go back to the overworld, I hit play. Now when we hit the button, it should load scene 1-1, and it does, and it's very obvious that's exactly what's going on. Cool. Infiniteg, thanks for the resub. 19 months. That is a prime number of months. McFire, never seen me here on Twitch before. I stream twice a week. Every week. Unless I'm, you know, out of the country or something like that. Every Saturday, every Wednesday. Thank you, Mace, for putting out the stream schedule. Okay, so we got some ability to switch scenes. Now, let's, most of these games have a little sort of UI pop up at the top that tell you what your current sort of score and lives are, right? So, excuse me. Let's make, I'm going to group this into an empty. We could make a panel, but there's not a real need to do that. I mean, I guess that would be fine. Sure. You know what? Just for visually speaking, let's make a panel. A panel is just a UI element that has a sprite on it, and that by default is set to be semi-transparent. So we're going to take that, we're going to make sure it is glued to the top and stretched from left to right, and we're going to give it a height of, I don't know, 50 pixels. There. So we have a panel at the top of the screen, and then inside of that, I'm going to add a text over here that says something like score, you know, just some numbers as placeholder, and lives, and again, as a placeholder over here. We're going to make the font white. I'll make the panel a little bit, I'll make the panel make sure it's a darker color. It'll help the text pop no matter what. And I don't know, we'll make the font a little bit bigger so that it's oop, that's too big. So it's a little easier to see. Text has to be, we have to tell it to fill the entire panel, and we'll then tell it to be centered and in the middle. There we go. So that's our GUI. Very beautiful. We're going to add, so this panel is called, I don't know, the score panel or something like that, and it's got text inside of it. And I'm just going to make a new script, Okay, I'll add it this way now. We're going to create a C# script, and this is something like score panel updater. And I'm going to attach this script to the text. And this script's only job is going to be to ask the game status to tell us what our current score is. At the score and lives, and it's going to update the text. That's it. So, I mean, there's a bunch of different ways to do it. What we're going to do is on every update, on every frame, we're going to say, let's find the game status. So we're gonna do this naively first. We're going to do something like game object. So we're going to get a game object. Hey, Slothy, thanks for the sub. In fact, I'm pretty sure that's a resub. I think you've been subbed before. Thank you very much, Slothy. So we're going to grab a game object. And again, this is, this is a relatively slow, bad way to grab the game status. Okay? So we're going to start with this, though. We're going to find an object called game status. And then from that game object, we want to grab specifically the game status. We're going to call it GS. And we can go go.getComponent game status. Okay? So it's the game status script that we actually care about. And here we should check to make sure that these things get found. In fact, let's put in a check. If geo is equal to null, this means we failed to find something called game status. So we're going to go debug.log error, failed to find an object named game status, like that, and then we'll just bail right away. And actually, to stop it from spanning the log over and over and over and over again, what I'm going to do is enabled, there we go, equals false. I'm going to turn the script off. This score panel updater, if it fails once, it's just going to turn itself off so it doesn't just keep spamming the log and keep us sane. But other than that, what we're going to do is we're going to grab that, and we're going to set, we have a component. We actually have to say using Unity engine.ui to say that we are using UI classes and objects and things like that. We have a component on ourselves called text, which has a property called text. And if we set that, that's going to be the words that show up here. So what we're going to do is we're going to set it to say something like score plus gs.score plus lives and the space plus gs.lives numlives. And there we go. So every frame it's going to run and update itself. Let's hit play and see if that works. It should set our score to 0 and our lives to 3, and it does. And if I were to click on game status, because those properties are public and exposed to the serializer, I can type in new things over here. There we go. We gave ourselves a bunch of points. Good. Excellent. Wonderful. So that works great. Now, if we hit the button, well, obviously we don't have anything up there. So we're like, we want the user interface to also show up in this scene. Cool. Easiest way to do that, I would say, is let's say we take the score panel that we put all this work into designing this beautiful score panel at the top of the screen. Shut up. It's beautiful. I'm going to turn it into a prefab down here. So then when I go into level 1.1, we already have a canvas. Let me just drop the score panel prefab inside of this canvas. There we go. It shows up there. And all right, it's not necessarily the most legible. I think maybe I'll make my camera background. Let us give it a little bit of color after all and darken it a bit. There we go. So it still stands out. A little easier to see. So now we have the score panel in the game. Cool. So let's go back to the overworld. Let's hit play. So our scores are updating here. Let's change our score to, that much. Excellent. That works great. Now let's hit the button to load scene 1 and see what disaster befalls us. We hit the button. The scores, the UI panel is incorrect, and we've got an error. Failed to find an object called game status. So, and that's indeed true. There was an object called game status in our overworld scene, but there's not one here in scene 1. And we're like, oh, yeah, okay. So here's what we're going to do. We're going to take this game status object. Again, I'll turn it into a prefab. Awesome. We're so smart. We're going to go to level 1.1, and we're going to drop the game status prefab in our scene 1.1. So, of course, things will work perfectly, right? And we can test that. Let's go back to the overworld. Yes, we'll save the changes. Let's hit play. It says 0 score 3 lives on our overworld, and we hit button. There, it's saying 0 scores 3 lives. So everything is awesome, right? No. So I'm going to hit play again from the overworld. And now I'm going to change our game status to say, oh yeah, we have 9,001 points, but we've lost life. We're down to 2 lives only. Okay, so that's good. And now we're going to enter into level 1. Why is our score 0 and lives 3? So, of course, the reason is that when we switch scenes, we still trash all of our previous objects and create new objects for the new scene. Every scene, every object in the previous scene gets destroyed. We can actually check this very explicitly. Our little game status script over here, we can add a event handler for onDestroy, and we can actually put in a little note that says game status was destroyed, because this actually runs when we switch scenes. Let's try it. If we hit play and we push the button, see that? Game status was destroyed. And then an entirely new game object gets created. So here comes the question that I get asked quite frequently. And in fact, when I asked people for suggestions for this live stream this weekend, I got more than one person asking about switching data back and forth. And the answer is, so there's more than one way to do that. Okay, but ultimately, we need to store data. We need to make it so that when we change from one scene to another, the data that we need to keep somehow doesn't get destroyed. And there are, I'd say there's probably like 3 major ways of doing that. Let's look at a few of them. Probably the one that you would use in this situation might be something like a don't destroy on load. But I'm going to save that one for last because we'll have to talk about the singleton design pattern and a few things like that. So there are 3 major ways to cause data to persist. I mean, there might be more, but 3 come to mind for me. Let's put in a note here. There are 3 major ways to persist this data between scene changes. Way number 1 is to save the info into something persistent. User prefs are one. A save file would be another. Oftentimes an actual save file might just get stuffed in user prefs, for example. But the idea is something that persists. And in fact, this would persist even not just between scene changes, but in fact between stopping and starting the game. Okay? Actually, I'll put in a note. This preserves data even between game executions, not just scene changes. Okay? So depending on what you're looking for, that might be perfect, it might be overkill, it might, not really matter one way or the other, but that's one option. Option number 2 is static class data. This is probably not the preference, because it's easy to goof up as a beginner. So static class information is data that belongs to a class, not to an instance of that class, not to an object of that class. And there's a certain persistence there that comes maybe a little bit unnaturally to the new programmer. Also, every now and again, anything that's static like this gets a little bit wonky in Unity, because when you're in the Unity editor and you play a game, and then you hit the button to stop the game from being played, right? So we hit play, we're playing the game, things are happening, and then we hit this button which stops the game from running. The game was actually running within the Unity editor memory, and I don't think the statics get cleaned up at that point. I think they do get cleaned up on the next play, but it leads to some really sort of oddball behavior in there. So there can be a little bit of gotchas, which unfortunately might come up once who just subbed? Farpoke, thank you very much for the sub. The third way, which tends to be the most Unity way, is using don't destroy on load. I did get that spelled correctly, right? Yes, I did. So, I need to bring up my window so I can see chat again, and I just changed it. This flags a game object. Technically, this is misread or mislabeled. Well, I mean, I guess it doesn't really matter. It's more like don't destroy on unload. This flags a game object such that when we change from one scene to another, it doesn't get destroyed. i.e., it is still present in the newly loaded scene. And that's quite interesting. But to use this to the best possible advantage, you need to use the Unity singleton design pattern, which is not a real singleton design pattern, but it's close enough. Hey, Zantano, thanks for the resub. So we're going to start with the first one. Okay, we're going to implement the first one. So what we would do with this is whenever data gets changed, we are going to want to save it inside the user prefs. Or instead of when it gets changed, we can save it right before we destroy, and that's what we'll do. So there's a couple of different ways to do it. One, if you were changing, points and lives and stuff, if you had, imagine we had some function called add score, which took in an integer, and some amount of score, and here we were saying score plus equals s. We could take this opportunity to save the score in a file /user prefs if we wanted. That would mean we were making the save every time the score changes, which might be kind of slow because maybe the score changes quite frequently. So instead what we're going to do, but depending on implementation, this could be slow / inefficient. Also, if you happen to have multiple places in your program where the score could change and you're not always using like one central function to do it, which you should be because it's usually really good to have one central function, but imagine that we don't. Instead, the better way might simply be when we destroy this game object, before we get destroyed, let's save our data to our save file. This is implementation number 1. Okay, that's the version of implementation number 1 for saving the data. So to do this, we would simply say, so there's do you not just go .user prefs? They change things on me, and I don't use user prefs very often. So, oh, it's player prefs. I'm calling it user prefs, but it's player prefs. That's what gets me, player prefs. Because I don't use this very often, so player prefs, there it is. So player prefs is an interesting little class. Basically, Unity, wouldn't an overarching class containing global data? Well, this is what this is. Game status is our global data. That's what this global status is. Major Cast said, wouldn't an overarching class containing global data be better? And of course, then you do open up the can of worms of, is global data good, bad, whatever. But in this case, game status is our global data, and this is basically just meant to be a container to hold all the stats, all the global data that needs to persist between loads. This is exactly what this is intended to be. If the game crashes, you'd lose all your score, though. Well, that's true. So, I mean, there's two things. If you save all the time, so on the other hand, if we are constantly saving the data on the fly, it means that we pretty much never lose anything to a crash. Depending on the kind of game you make, you may want this. But here we're going to say on destroy. So if you quit the game or if you change scenes, we'll save the data. So player prefs is a class that basically Unity has sort of a built-in save file that is cross-platform. You don't care where it gets stored. You don't care about like creating files, destroying files, worrying about anything like that. It doesn't matter if you're on PC, Mac, Linux, if you're playing through the web player, if you're playing on a mobile device, it doesn't matter. This player prefs is a file that exists, and you can write stuff to it and read stuff from it just by reading and writing through various keys. So in this case, we're going to write an integer, right? Our score is an integer. We could have a float, we could have a string, but we have an integer, obviously. So we're going to write an integer. It needs a key. So we're going to call this score, and we need to give it a value, which in this case is score. And while we're at it, we're also going to say player prefs.setInt lives, and we're going to give it num lives over there, which maybe I should have just called lives. Anyway, that's fine. So now, when we change scenes, this will happen whenever this object is destroyed, which includes scene changes as well as simply exiting the program. All right, so right before this object actually gets destroyed, it will save the score and the lives to the player prefs. And then how do we get that back? Well, we just read it in. And when would we do that? Maybe in the start, right? So again, implementation number 1. Load data from player prefs. This might be from the previous scene, or maybe even from the previous execution, i.e. saved between quitting and reloading the game. So to do this, very simple. So player prefs has a function called getInt. GetInt takes in a string, which is our key, so score, and returns an integer. So we say score is equal to that, and that will load that in. It actually has an optional second value, which is the default value. So what do we want? If there's no key called score, what should this function return? Well, we want the scores to start off at 0. So there you go. So it'll have a default value of 0. If score doesn't exist in our save file, it'll return 0. Otherwise, it'll do that. Then we'll do the same thing for num lives, and then lives over here, because consistency is for suckers. And we are going to set it to 3. There we go. So start executes when we start when the object runs. Technically, start runs immediately before the first update gets called in an object, which is slightly different from onEnable, but this should work. So now if we do this, let's give this a try and see what happens. We're going to go into Unity and hit play. So I'm on the overworld. It ran for the first time. The start function ran, which caused us to check player prefs for the values. Technically, these values didn't exist yet, so they got set to the default of 0 and 3. Let's go in and intentionally change it. We're going to change our score to over 9,000. So now we have a score of 9,001. Let me go. I'm just going to switch scenes. I'm going to hit the button to switch scenes to a level 1. Level 1. So what happens is still, when we switch scenes, right before we leave the scene, all the objects are destroyed, and right before all the objects are destroyed, the onDestroy function gets called, which tells our game status, hey, let's save out all our data to player prefs. And then the objects all get destroyed, a new scene comes in, new objects get created, and then the new game status object gets its start function called, and what it does in start is it reads from player prefs, and so it loaded in our saved data. And again, this will persist between games. So if I stop the program, and I hit play, we start a new program, we get a new set of scores. Now, you can, if you want, you could do a variety of tests to see, there's ways to check to see if this is a new execution or not, if it's a scene load or not. So maybe you will want to initiate the scores back to 0 completely if it's the first load, which is fine. There's lots of ways to do that. Basically, if you want to do that on the main menu, if you click the new game button, actually that might be a great idea. If you click the new game button from the main menu, what it should do is it should just delete the player pref info or reset it to like 0 and 3, right? Whereas if you hit load, then it doesn't do that. Then it just lets this do its own thing. But it's a little bit, it's a little bit rough. We got a few questions. How would you do that when saving an inventory? So that's a good question. The player prefs are relatively simplistic. They only save integers, floats, or strings. It doesn't mean that can't work. You could do something like, so if, let's say we had an inventory program, right, where, so you do something like player prefs dot set string in, so this is slot 0 of your inventory, the name of that, so you call it, you're storing your data from some other variables, but this is, your longsword, and then you're saving in player prefs dot set int inv0 weight, and this has a weight of 15 whatever, etc., etc., etc. This is a little bit cumbersome, and usually if you have any sort of real complex data, you don't tend to use player prefs like this for a couple of reasons. One, player pref only has quote unquote one save file, right? So how would you have more than one save file? Like, because right now there's just one slot called inventory 0. So, you know, the first slot in your bag contains longsword, and that's it. You just have one save. Again, you can sort of brute force it, where you could imagine that every single one of these player pref entries have something like save slot 0 at the start of them. And then you'd have another one called save slot 1, and that sort of thing. And you could, you know, construct this with a string. So string save slot is equal to save slot plus my save number, and something like this. And then you could use that as part of this code over here and whatever. But it starts to get really, really, really messy. So what you will generally do, undo some more. More. Whoop. Come on. There we go. So what you'll generally do instead is you'll probably come up with some other saving system. Something like what we're doing in Project Porcupine, where we're serializing our code to like an XML file, right? In Project Porcupine, we save our data as XML, which is just string data. And actually what we're doing right now in Project Porcupine is we're using player prefs, and we're saying set string save game 0 to be my XML save info. Is basically what we're doing there. We're taking all the XML, we're taking all our game data, convert it into an XML string, and we could save that to a file, but we just stuff it in player prefs, which is fine. And then you could have multiple save games over here. You could decide that you're going to implement a fixed number of slots, or you could have an unlimited number of slots by just, you know, continuing to add +1 to the save game number. And that is one way you can do it. If you're at a certain point, if you got a lot of data, you can run into certain limits about player pref storage size, particularly just only I think for the web player basically, or the WebGL, at which point you might want to look into some other solutions, but that's well beyond the scope of this particular tutorial. Hope that is good. Ginger Cookie with the 2-year resub. Thank you so much, Ginger Cookie. Oh, there you go. You just posted earlier. 2 years warning in T-10. Thank you so much. And yeah, custom save files, man. Yeah, so that's the thing. Like, we can stuff the XML inside of player prefs, or you can go through the process of actually opening a file on the file system of the computer that you're on and stuffing your XML or whatever, your binary data or anything you want in there. So that's it. But that's, again, beyond the scope of that. Are there any reasons why using XML and not JSON? I love JSON. JSON's definitely one of my favorite text-based data types, especially as someone who came from a web dev kind of thing. JSON is just beautiful and wonderful. I used XML in Project Porcupine simply because XML parser is built into the version of C# that Unity uses. If you do have either Silverlight loaded, or there's some great open source libraries that you can throw into your C#, there are some excellent JSON sort of reader writers that are available on there. Love them, but we just used XML because that was what was available in our library without having to add any third-party stuff. So that's that. Because if you want to use XML in Unity, you just go, using XML. System.xml? There it is, system.xml. And there's more after that. There's your schema, serialization, all that. Sort of built into the version of C# that Unity has. Okay, so that is the implementation number 1. So we save the info into something that persists, which has the side effect of persisting between game executions, which might be good, might be bad. We don't know. All right, second version here is the static class data implementation. So I'm going to delete what we've done so far and re-implement this using static data. So we're going to delete where we bring this up, and we're going to remove this from the onDestroy as well. Actually, I suppose I could just comment it out. Yeah, maybe I'll do that. Boop, 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 boop. So it'll still be here. This code will be uploaded later on. Okay, so now we're back to the version of the code where nothing persists between either loading or exiting the game, nor changing scenes. Nothing persists because we don't sort of save it anywhere, and we don't try to load that data anywhere. So it will be lost between runs. Hey, Truncate Tables! Thanks for the resub. Unity does have built-in JSON support now? Does it? Really? Oh, last time I did it, it didn't. Or maybe I didn't check it right. What do you have to include for that? I mean, because I know, like, it's not part of the C# library that's there. Did they just add their own as part of like web support? That's probably something that happened. Anyway, we'll revisit that later. Maybe next tutorial we'll be looking at ways to save data out to JSON and XML and different stuff. Okay, so we're going to implement this sort of static class data. So static class data, as I said, is a variable that instead of belonging to an instance of a class, it belongs to the class itself. And we can do that very simply by declaring it static. So now these two variables belong to the class as a whole. All objects of that class will use it, and in fact, if it is public, we don't have to grab an instance. So here, this is our score panel updater. We are finding, in the score panel updater, we're finding a copy of game status, then we are grabbing the game status component from there, and then we are writing out the data from that. If we have static data, we can actually ignore all this. Boop. We're going to comment all that out, and instead, we can just say, hey, I want the game status class dot score and the game status class dot numLives, because those two variables belong to the class as opposed to an object. So I don't need a copy of the object. But that's quite cool. Yeah, pros and cons, but it's quite cool. These will get instantiated to 3 and 0 when the program loads. When the program loads, these two variables will get set at that point. They will not get reset to 3 and 0 every time you instantiate a new copy of game status. They only get set once when you first run the program. But other than that, we can use it like whatever. You know, we can add score, we can change it. It will likely break. Yeah, in Unity, we'll no longer be able to set those values in the editor. We could do a custom editor window and whatever. Let me create a little button here. I'm going to create an extra button, just duplicating this one, and I'm going to shove it to the bottom right, and I'm going to label this one to add points, and label it up here as well. And what this button is going to do, when you click it, it's going to call the game status classes add score function that we put in there, and we're going to have it add 9,001 points. So when we click that button, it'll add points. So let's hit play. We should start with a score of 0 and 3 lives. Excellent. And if I hit add points, it will add 9,001 points to our score. We can hit more than once. There we go. If I stop the program and if I run it again, we'll once again be at 0 and 3. So let's add some points here. Let's hit the button to go to level 1-1. And level 1-1, our score is still there because we are reading this score from the variable that belongs to the entirety of the class because it's a static variable. So that's another way to persist data. It's really, really, really simple to do. And this is sort of like a true classic global variable, like in the olden days that were considered very bad. These are these global variables. Here it is encapsulated sort of in a namespace by virtue of being part of a class, but we still don't have a lot of like babysitting in this variable, and it's possible to write bad code somewhere else that, you know, does silly things to this score. But it does work. And actually, we don't need, this is an important point, we don't need this these two variables to be public. I was doing it mostly for convenience of the editor, but we could set these to be protected, so that way nothing outside of the game status class can read or write this, which does mean we'll get an error right now. If we go and flip back into Unity, we will get a compilation error because this code right here is trying to access those two variables, and they are protected. We want them protected so that the only way to change your score is by calling, say, this add score function. But if we're going to do that, we're going to need some way for our outside program to read it. We could use, of course, like get set sort of stuff, but let's just go and make a public function here called get score, which returns score, and a public int called get lives. I should just call it lives. You know what? I'm going to do that. Instead of num lives, I'm going to call this lives. There we go. Add to a lot of sanity. Get lives, return lives. Now, what we can do, it won't quite work here because we haven't made this static, but presumably what we could do is go GameStatus.getScore and GameStatus.getLives, but this will give us an error. And the reason is this type of function here, a normal function, must be called on an instance of an object. But here we're just trying to call it from the class itself without grabbing an instance of the object. So if we did have an instance, if we were still grabbing this instance of GameStatus and going gs.getScore, this would work. But because we aren't and we're just trying to call it in the class itself, that will be fine as long as we say it's static. And I typically write it public static. It doesn't actually matter. Public static. So now we're saying that these are static methods, which means they can't interact with anything that normally would need an instance. But in this case, we don't need an instance. We're just using score and lives. They're both static. So now that will run. That will compile. And yeah, add points, hit the button to load to the next scene. Boom, done. So now we have a bit of a cleaner thing still because things are protected. This is the implementation 2, static class data. It's not that easy to goof up as a beginner, really. But there is one tricksy bit in that, and this won't come up with integers like this, but technically when you stop running a program in Unity, I don't believe it goes and cleans up all the classes because it's still running the same memory. So anything you have set would still exist in the background of Unity in sort of a weird, awkward way that you might not expect. And when a program exits or when it starts, sometimes depending on your code, you can end up with really weird messages that imply that something is off or broken because it's trying to read a static that doesn't exist anymore because it's left over from the previous execution. 99% of the time, it'll be fine. But that's one way to do it. Okay, and it works great. You know what? Let me rename this. Very simple. Occasionally leads to weirdness from inside the Unity editor, but not actually breaking things. You could do really bad, well, not bad, but, really messy global style variables with this. But you can also do really nice encapsulation as well. So that's fine. Static class data. Now we're going to go with the most Unity style implementation. So remember that with this game object is still being destroyed. So our game status, whenever we leave a scene, this game status instance still goes away and then later on still gets created. Now, one interesting question is this. Do we still need a game status object in our game? And the answer is actually no. If we never instantiated game status, right? Let's say we didn't have this object over here. If we never had this game status, all our static data would still be there, and our static functions would not run. Currently, I couldn't show you this without game status because of we do need an instance of it just for this add score and load scene to work, right? But if game status wasn't in here, if we had got rid of this function and maybe got rid of the start and all that, we would never need to instantiate game object. It could just be a pure static class purely to contain data, and that would be great. But we'd need something external to process. We'd need another class that you might instantiate to actually do, your scene loading. I mean, this could be static here. The problem is a button by itself in Unity, a UI button, can't call add score on just a static class by itself. Your button needs to point to an object. So for the convenience of this example, we have to have a button there. But this could be a pure static class, and it would still work pretty damn good. All right, so let's go and do the third implementation, which again is the most Unity style of thing. So what this does is if we set don't destroy unload on a game object, then when a scene becomes unloaded, it doesn't destroy the object. So it will persist in the next scene. Let's give that a quick go. I'm going to remove everything from our static implementation. So I'm going to basically remove all the words static everywhere. So we will no longer have a static class. Well, we don't have a static class right now, but We're going to remove all the static bits. Get rid of all that kind of nonsense. We need instantiation. It's not nonsense. Static classes are really good. This will break this code over here because we no longer can just grab get score from the class itself. So we're going to have to go back to the version which grabs a copy of game object and then does stuff. Although we did make score private, so we're still going to have to use get score and get lives, which I think is probably an upgrade. So now we are back, assuming things are okay. I believe we are back in the version where things don't persist. So if I hit play, we get 0 score, 3 lives, add points. We get 36,000 points. If I hit the button to load the next scene, everything has just been reset. So we're back at a non-persistent version. So what we're going to do is we're going to add game object dot, no, it's not like that. It's game object dot don't destroy on load. So this is a static function on the game object class that requires that you pass it some sort of object. And typically what you do is you pass it our current game object, right? This is our current game object, the one that belongs to this game status. I mean, it's the same, this dot game object, exactly the same. So our game object from this, hey, Rock Dog, thanks for the resub. 1 month shy of a year. Thanks, Rock. So our game object, we are going to tell the Unity system as a whole, please don't destroy this when you load. So what's going to be interesting is every time we've changed scenes at this point, we've gotten this message in the log. Game status was destroyed. If I hit play right now, Zote, thanks for the resub, the 1 year anniversary. Thank you so much. If I then quit the program, I'll still get the message that the game status was destroyed. That's still working. Now I'm going to hit play. I'm going to hit the button to change scenes. Notice I did not get a message to tell me that this game object was destroyed. But there's something that's happened. We now have 2 game statuses in here. One of these game statuses is from the overworld, the first scene. The second game status is the game status that is in scene 1-1. This is why I say, so this don't destroy on load is the most Unity style there is, but it leads to a lot of complication. And honestly, maybe I really should just be encouraging you guys to use the static class data thing, which is actually what I tend to do a lot internally. But anyway, let's move on. So because level 1-1 has its own game status, we end up with 2. Okay, and we know, like, obviously this is not a great thing. So let's get rid of the game status object from level 1-1. So we've gotten rid of it. 1-1 no longer has one. Main menu, sorry, not main menu. Overworld has one, game status here, and we know it's not going to be destroyed on load. So let's hit play. Let's give ourselves some points. Hit the button. So new scene loads. Our game status from the overworld is still in our scene. It just got carried over because it didn't get destroyed. And our canvas, our UI over here, can successfully read from this. That's great! Now we have data that persists between scenes. But there's one more tricky thing to worry about. It's like, oh, that's wonderful. Now we have a single game status game object that persists throughout the entire program. It doesn't matter, you know, how many levels we go to, right? If we go from level 1-1 and we go to 1-2, game status will still be there. That's cool. But what happens when we go from level 1-1 back to the overworld? So let me make, and actually I should have done this from the start. Instead of having game status change scenes, let's make a new object here, and we're going to call it the scene loader object. And we're going to give it the function. So we're going to give it a script called scene loader. I'm just trying to figure out how to get the button press to work the way that I want. Yeah, it's fine. Scene loader, and in here, I'm just going to grab from game status. And actually, we're moving more and more towards what should be a purely static class of game status, which should tell you something. I'm going to grab this load scene function out of game status and just move it over to scene loader, which really has no other job but to load a scene. Using Unity engine.scene management. There we go. We're going to go and tell our button over here. Which button is it? I really should have labeled this. Ah, there we go. So this button is load scene button. So it can no longer call the load scene function on our game status script because that's not where it is. So instead, it's going to point towards the scene loader object and the scene loader script and load scene, load level 1-1. And then what we can do with this is I can go to level 1-1, and let's assume we have a button here. And this button is the win level, go back to overworld. Okay, this is just representing what would happen, you know, when you finally get to the end of the level. Okay, I guess we'll move the button down so we can still see we're on scene 1-1. And you can hit this button to win the level and go back to the overworld. And to do that, I'm going to just go back to actually the overworld, make a prefab from our scene loader, go back to level 1-1, drop our scene loader in here, and just tell that button to, when you get clicked, tell the scene loader objects, scene loader class, the load scene function, and just tell it to call to send the scene back to overworld. So let's try that again. We're going to go to overworld. We're going to hit play. We're going to hit the button here to go to scene to level 1-1. We're in level 1-1. We correctly have a game status. Actually, let me run this again. Right? So we have 18,000 points. We hit this. We go to scene 1-1. We have 18,000 points because that game status object was not deleted. Now we're going to win the level. We're going back to the overworld. And once again, we find ourselves in a situation where we have two game statuses. Two game statuses. The UI here is still giving us the scores successfully. The reason it's doing that is because when our UI script is running, over here, it finds the first object of the name game status. And it just so happens that's still the original one. So our UI still looks fine because it's still grabbing the first game status with the 18,000 points, not the second game status, which has 0 points. But every time we switch back to level 1-1 and then back to the overworld and then back and forth and back and forth and back and forth, we end up with a new game status, all of which don't delete themselves, ever. So this is the problem. And this is the gotchas with the classic Unity way to have data persist, is you have to think about this. Like, right, now we have all these extra game statuses. So, all right, what you might think to do is, what if we go backwards? Yeah, we're going to be making a singleton. Don't worry about it. But you might be thinking, let's take it back a step. Let's not create this object on the overworld. Let's create it on the main menu. If we create it only on the main menu, then at least every time we switch back and forth between the level and the overworld, it's not going to create more. Although every time you go back to the main menu, then it's going to create another one anyway. See where it's going? Hey, Loler, thanks for the resub. The final problem is this. It's if you're trying to test level 1, right? If you're trying to debug something level 1, every time you want to test it, do you want to start from the main menu, load the main menu, click Start Game, go to the overworld, move yourself over to level 1, hit the button to load level 1, and then finally get to see if level 1 is working or not? No, you don't want to do that. In Unity, you want to be able to be working on level 1 and just hit play and have it work. But now it doesn't work because our GUI is trying to find an object called game status. So there's two problems here. The first is we end up with extra copies, and the second is testing is a huge pain in the butt. We can fix this, though. And this is going to involve the Unity design problem, or Unity design pattern, I should say, or singleton. Unity singleton design pattern. So a singleton, the idea of a singleton in programming is a class where you can only instantiate a single copy of that class. And every language has slightly different ways to do it. Some are somewhat more built-in-ish than others, but a lot of them involve sort of just going out of your way to check things. They all have issues, and there's, you know, singletons are a source of religious warfare among programmers, even in Unity. But I'm going to show you how to do it so you can decide how to do it. So here's how it works. We want to be a singleton, right? We want to be a singleton, i.e. there should only ever be one game status instance at any given time. So how do we find out if there's more than one? Well, we could ask Unity to tell us about all game objects or all game statuses that are out there. We can do a game object dot find game objects of type game status, which would return an array of game statuses. And then if there's more than one, then something's gone wrong. But how do you pick which one of them is the real one? Well, I mean, you could just, the first one or whatever. But every single copy of this is running the same thing. It gets very awkward. The way to do it is we keep a pointer to ourselves. We have a static game status called, most people call it current, or instance is very popular. So I'm going to make it really explicit. This is the one and only game status. Is that wordy enough for you? Now, because it's static, all instances of game status will just share this one variable over here. So what we say is, I want to be the only one, and I want to never die. Okay, all right, that's step one. But what happens, again, so this is on the overworld, that gets set, and that's groovy. Then you go to level 1, and then you come back over here. Okay, and then you get a new copy of game status. You've got the one that doesn't die, and then the brand new one that we got from loading in the scene. So what we do is before we set ourselves as this is the one and only game status, and before we set ourselves as being immortal, right? Become immortal. There can only be one. Oh shit. We are a Highlander. Should call it the Highlander a design pattern. We are a Highlander, become immortal. There can only be one. So if someone else, if this is the one and only game status is not null, what does this mean? Someone else is the one and only. Someone else is the singleton already. So let's just bail. So let's just destroy ourselves before we cause trouble. So we're going to say, hey, just destroy this game object, because we are not the one. There is already the one. So we are not the one, so destroy ourselves. And also, let's return right away out of the start so that, it doesn't run more than, so that we don't run anything else. But if we get here, then we are the one. Let's act like it. So what this does is we're going to hit play. We're in the overworld. We have our game status. Our game status just set itself as the one. We're going to add some points. I'm going to hit the button to go to level 1-1. Because game status is set to do not destroy, obviously it's still fine. Now we're going to go back to the overworld. And when we load the overworld scene, there's going to be another game status over there. But when it runs its start, it's going to know that it's not the one, and it's instantly going to kill itself. In fact, we even get a note that it went and destroyed itself. So the game status that was there when we loaded the scene knew it was not the one and killed itself off automatically. So now we don't get multiple copies of game status, which is good. The other nice thing about this is then we can go and put one of these game status objects in every single scene. Because right now, if we load level 1-1 directly in the editor, and then we hit play to run this scene directly in the editor, there's no game status. So our UI reports that there's an error, right? Plus, if our guy's running around and he goes and stomps on a Koopa, we're not going to get 100 points added to our score because there's no game status to add score to. But now, I can drop this game status prefab back in here. And in fact, we can now have a game status prefab in every single one of our scenes. So now if I hit play, there's a game status prefab. We get no errors, everything is groovy. If I go from this scene to the overworld, when I load the overworld, again, the game status that's waiting there immediately discovers, oh, I shouldn't be here, there's already one of me. And I can keep flipping back and forth between these scenes, back and forth. So if your game data only needs to maintain simple data, okay? If all you need to do is keep track of a little bit of score and lives, right? Then really what we should do is this is the ideal implementation if your persistent data is just that. Data. It doesn't do anything. It's purely, or it can be implemented as a purely static class. Then option number 1 is good. Basically, it's just acting as a big global dictionary for your data. Option 2, or option 3 over here. Option 1 has its own, possibilities. Option 3 is, this is the ideal implementation if this class needs to do things, not just store things. In other words, maybe you need it to have an update function that, modifies the game data regularly and will need to do so on every scene. So what do I mean by that? Like literally, if there's something that always has to be changed in the data, no matter what scene you're in, and has to be doing that in a sort of persistent way. Imagine you're playing a game where you can switch back and forth between scenes, but there's a timer counting down constantly, okay? Now, what you could do is you could have a purely static class that just keeps the current time, and you have some other script somewhere that keeps updating the time. But now, you have to make sure that that other script that keeps updating the time is present in every single scene as well. And so if you already have that concept where there's a certain script that needs to exist in every single scene to do things on my global data, you could just have your global data be this sort of persistent don't destroy on load kind of structure that just exists. You have one game object you know exists in every single scene, and it's the same one, and it doesn't matter what scene you start from, it will be there correctly. I often tend to do this. I tend to work a lot with pure classes in general. So the idea of like a pure static class is very appealing and is a great way to store data. And again, this is very simple. This is a very simple, very minimalist implementation. Has the benefit of true persistence. Also, you don't need a single central class to store data in this way. Each object could load its own info. Although, again, whether that's appropriate or not depends entirely on your stuff. So hopefully this is a good set of tools that you've got. I really like this. And this is the one. If you go and look up anything about Unity and how to have data persist between scenes, they tell you to use don't destroy on load. And don't destroy on load is very powerful, but man, it is loaded with gotchas because you need this sort of singleton design pattern. There's one little bonus here, right? With this is a static variable called this is the one and only game status. Let's rename it something saner. Let's rename this to instance. Actually, we're going to rename it to lowercase instance here. There, that's a lot more sane, and that tends to be what people use. So we've got this one and only static link pointing us to the one true instance of game status. Our score panel updater, instead of finding the game object, which is arguably a slow operation in Unity, especially if you're doing it every frame. It's not that slow, but it's not great. It might be better to do it in the start, for example, right? So in your void start, here you could grab a copy of your game status at this point. But what we can do is, hey, all we're looking for is the instance of the game status, right? The actual game status object itself, not the game object, but the game status object, the instance of this class. That's what we're looking for. Why don't we skip the find and skip the get component and just read directly from instance? We could do very easily if it was public, but that opens up a lot of problems. Let's just make, I don't know, we'll just make a little property here. I guess we could make this a property. Whatever, let me just do it this way. I'm going to say public static. Oh, it could be a function as well. Here, we'll make it clear with a function that tends to be a little bit more accessible to everyone. So it's a public static function called getInstance. And all it does is return instance. But it means that no one outside the program can actually change where this is pointing. You'll get a copy of the instance, but you won't be able to change this particular variable and mess up everything. So now we can, again, comment out all of this and just say something like GameStatus.getInstance. Or I guess I still need most of this line here. and we can say GameObject.getInstance.getScore. GameObject.getInstance.getLives. That should compile. What did I goof up? Oh! This has to return a game status. It doesn't return void. It returns a game status. There we go. Oh, I didn't realize the program was still running. There we are. So now this is updating. Let's go and give ourselves some points. Or not. Oh! Add points breaks. Yeah, that makes sense. The add points button is trying to point to the game status that was in the scene in our editor, but the button is now broken because it's not pointing to an object anymore, which is fine. You're not usually going to be adding points this way. Instead, you could have a script attached to this, and that would be the way it would correctly work. This add points button should instead be doing, basically, the add points button just has to say, hey, game status, give me your current instance, dot get instance, dot add score, and then we add 9001. That's all the button has to do to add score to our correct instance of game status. And this is also very fast because you're just accessing, I mean, technically this is a function call, but function calls like this get optimized like crazy. So effectively, this is exactly the same as if we were able to access this variable directly. And it's insanely fast. So then we can just get it directly. And that's very handy. Now, you don't have to do GameObject.find. You don't have to do GameObject.find object of type. You don't have to do from your GameObject. You don't have to do .getComponent or anything like that. You just go GameStatus.getInstance.blah, which is really good and really fast. I think, hopefully, that's relatively clear. One thing, when you show someone multiple ways, they might get confused about the number of options and which way is the right way and get confused between the two, or the three in this case. There's not really a better option. There is sort of an option that is more optimal for whatever you're trying to do. Whatever you're trying to do, you can do it for sure using any of these three methods. But one of them will usually be a little simpler or a little faster or slightly more convenient is what it comes down to. Like if you really want a game, and a lot of games these days just have one save, basically. They have one set of persistent data that persists between game loads, and that's that. Player Prefs is the ideal way to do that. It just has one basically save file. We did show you how you could have multiple game slots with this. It's a little trickier. Also, if you have really complex data, this gets a little bit more annoying unless you go and serialize all your data to XML or JSON or something. But that's a whole nother topic. Class data, very good, mostly when things don't change, or you're okay with having an outside script being responsible for changing the game data. And then finally, this way here is the most Unity way of doing it, which does have a lot of caveats, although it is kind of interesting that you can keep an actual game object alive throughout the entire execution of your program. So what we're going to do is there is no real right in programming, only better. Yeah, there's arguably something that, any particular algorithm, there might be one way that is faster than every other way, but is that better because maybe it's not as flexible, maybe you can't understand it? Like, I used to write a lot of Perl code, right? And I would be very used to writing a lot of Perl code that would look like, something like this, and a little tilde at the top. Where's my tilde anymore? Right over here, and then an escape like this, and then another slash here, and then here I would have a /1 doing some stuff. And it's like a perfectly, of course we're going to have like a bunch of, we're going to have some parentheses over here, and a star, and then a dot, question mark, and then another dot and a star. That's excellent Perl code. Maybe, I don't know, it's been ages since I've written it, since I've done anything like this. But that is not necessarily the best way, just depending on, if legibility is something that counts, and it does count, then maybe there's that. So anyway, there's a lot of things, and there will always be holy wars about different implementations, but hopefully that gives you a few tools in your tool chest. Essie, thank you very much for the resub. 25 months in a row. Thank you, Essie. A wild regex appears. I love regexes. They're a great way to parse text stuff. I haven't worked with them in ages because it's been a little while since I've done any sort of web dev, which is mostly where I did a lot of my text programming, especially when I worked in Perl. Although you can do regexes in basically every single language. I think C# has got like a class called regex, doesn't it? You probably have to include something. Anyway, we're going to take a very short break. When we come back, we're going to do something a lot more sort of just fun and silly. We're going to make sort of a 2D top-down car racing kind of thing. It'll take us like 15 minutes to throw this thing together, and it'll be kind of a blast. The sort of thing that's very well suited, whether you're playing mobile or whether you're going to be playing on a console type thing. We'll look at a few of those topics, and it's a hoot, and I hope someone uses that to make a really fun little car racing game. So give me 2 minutes just to have a bio break, and when we come back, we'll have a new little project open up here, and we'll do a little bit of car programming. It's going to be real cool. See you guys in a couple. Thank you to everyone who pledged to support this in February and is making these videos happen through March and early April. And of course, these mic check supporters. We've got Wes Eldenboving again, Craig Mortel, Nail Vikstrom, Neil Blakely Milner, Speedy Savant, Valent Cake Fiend, Aaron Toyson, Marius Field Vold, Ole Peter Talgo, probably Ole, Julian Ogier, Lafone, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and Andrew Henninger. And everyone who just watches and shares and favorites and comments and subscribes, thank you so much for just continuing to make these videos a thing that we can do. I think it's pretty awesome, and I hope you do too. See you next time, folks.